Okay, good morning, everyone. It's my pleasure to be here. Thank you for the organizers for giving me this opportunity to share our work. So I teach and conduct research at IIT Bombay. The work I'm going to present is done by my students and project staff, of course. I take the credit to present it here. It's a large team that is working right now actually in the field, but the major work which I'm presenting here today is done by two of the people, Saurav and Nupur. This work is financially supported by the DBT and Wellcome Trust, the Team Science Grant. Just to give you an overview, this is a field study, it's a part of a pilot that we are conducting in our country in 4 urban centers. Those are Mumbai, Delhi, Mysore, and Bangalore. It's a multi-centric study, multi-investigators led by Dr. Mahesh at JSS Medical College, Mysore. AIMS and St. John's are also partner to this. So in this, we are longitudinally assessing the lung function in adolescents from 11 to 13 years at recruitment. Going to follow them for 4 years, up to 17, 18 years of age. We will going to measure their air pollution exposures as well as physical inactivity and nutritional kind of, let's say, diet-related things, and then also look at CC16 and some of the inflammatory markers as some kind of prognostic markers for lung function deterioration and later morbidity in life. In terms of air pollution, we are going to look at PM 2.5. Everybody knows, I think, in this room. I don't need to tell you that this is one of the most important parameters. This is a longitudinal study, as I said, started in 2020 December and up to 2025. I think I don't need to tell to this audience here, all of you are luminaries in your field, but it is important to understand that particles are actually invisible. And air pollution, we can say mostly invisible clear, and mostly we are talking about particles which are very small, which can infiltrate deep into our alveolar regions. For example, fine particles, which are particles having aerodynamic diameter less or equal to 2.5 micrometers, and you can see the comparison with the human hair. That is also because of their penetration, while the particles which are more than 10 micrometers are not able to, right? Important thing in particles specifically, unlike gases like NO2, SO2, etc., is they are complex mixture. So they can have a lot of things which are basically, it could be in solid and liquid phase, and they vary by size and also the origin. And in this case, I'm going to focus on heavy metals, and many of you know that some of these heavy metals are toxic and can cause a lot of problems. So I don't need to spend much time here. Just one thing I want to mention. It is not that air pollution causes 7 million deaths or premature deaths. It is attributed, right? It's association. So we are saying that it can cause. So these numbers can vary as soon as the next study comes. Important thing to keep in mind is many of these numbers are not necessarily coming from the studies which are really generic from our country. So just we should keep careful about that. So essentially, chronic exposure to toxic metals are known to affect adversely, specifically like nephrotoxic, neurological, neurotoxic, cognitive kind of effects mostly, right? And biological samples can be used as an important indicator for their concentration in the body. So if we can measure the metals which are of anthropogenic in origin in different age groups, for example, in this case, children, they get bioaccumulated, and then we can measure their exposure in the body. The study is done in 4 areas, as I mentioned: Mumbai, Mysore, Delhi, and Bangalore. This is a pilot study, so we have taken about 30 homes, in sense 30 subjects from these places. As I mentioned here, in this case, what we did, we collected hair and nails from these children. Actually, the study is being done for about 5,000 children in all these 4, about 1,200, 1,250 children all over. But for this, I'm just going to present only from the 30 of those subjects, where we had also air pollution measurements done. This is how it is done. Like, for example, we used low volume air samplers with about 5 liters per minute of airflow rate. We put them outside their balcony, their like some kind of windowsill if it is open to the air, and we measure for 24 hours. In this case, we measure for 1 week, 7 days. We collected the hair and the nails, and then we process them in the lab. So for example, either they were extracted with some acid, microwave acid digestion was used, or for example, first water and then total extraction, and then finally they were analyzed using ICP-MS method. A few of the results, if we just show you the PM 2.5 levels in these 4 cities, out of these measurements only, you can see that, not a surprising thing, Delhi is the one which is having the highest levels of PM 2.5, while, for example, Mysore is the lowest. That was by purpose, that was the design of the study, because we wanted to have the kind of a gradient in air pollution so that we can look at the lung function later. Now, if you compare that, because I saw some of you use air quality index, which is a little composite kind of a measure, but if you look at PM 2.5 concentration there, for example, you can see that for Delhi it is already in the lightly polluted kind of category, and so, right? Mysore is only place where we can say it is good. Now, important thing to consider is not that in Delhi, like everybody is highly exposed, or in Mumbai and Bangalore, everybody is low exposed. Within city also, we have exposure differences. Those who are living near roads, or for example, to major industry or sources, they are more exposed. You can see that how a traffic, urban background, which is residential kind of locality, and regional background, which are actually the campuses of AIIMS, IIT Bombay, JSS Medical College, and St. John's in Bangalore, you can see have the lowest concentrations there. Now, coming to like the major thing what I wanted to show today is the concentration of at least these selected toxic heavy metals in hair, nails, and PM 2.5. Sorry for this very, very congested table. The bold values show which are the cities which are having the highest levels. So what you can see here is like most of the first panel, Delhi is showing most of these bold numbers. So in Delhi, not only the PM 2.5 levels are higher, also the metals in the PM 2.5 as well as in the hair and nails of the children are higher. But it is not very consistent. In some cases, as you can see here, it is also in some other cities. When we looked at them together, for example, by site types, what I can just mention from this graph is like the 2 bars are showing you the hair and nails, and this line is showing you the PM 2.5. And you can see that at many places, the line is also going along with the bars. So what it's telling, the metals, for example, copper, or for example, cadmium, or let's say arsenic, some of those are higher in the PM 2.5 at traffic sites, and they are also higher in the children whose homes were near the traffic sites. So this is pilot. We cannot conclude too much from this, but at least this gives us some insight into this. So I just want to summarize. I mean, we did some kind of risk assessment. We tried to look at correlations. I'm going to summarize it here. So toxic metals like chromium, cobalt, copper, arsenic, etc. were found to be highest in Delhi, the lowest levels in Mysore. Not surprising, we saw that also for the PM 2.5. But that we also saw for some of the hair and nails also in the children. And not only for the cities, within cities we found that the traffic sites show higher levels of toxic metals than the urban background. Yeah, I'm almost done. We saw the correlation. Some metals in hair and nails show high correlation, significant correlation, mostly about 0.7 to 0.8 between PM and the hair or nails. But the relationships are not consistent. So obviously we need more data to look into that. We calculate the risk, for example, both carcinogenic and non-carcinogenic. For example, hazard quotient, all of them are low. So I mean, this is like too early to say much about that. So now what we can conclude, at least from this pilot, is the heavy metals in particles as well as in the hair and nails or the biosamples are mostly of anthropogenic nature. We found they are more in the traffic, near the traffic sites or so, and primarily in that sense they come from vehicular and sometimes from industrial emissions. Currently our air pollution measurements are being conducted in about 60 locations in each of these cities. Right now we are doing in Mumbai and Delhi about 120 locations, and the major goal is to then look at the effect on oxidative potential as well as the lung function of these children. Yeah. So thank you very much for your time, and I would like to take any questions you have.
Thank you, Dr. Phuleria, for your presentation.
Where PM 1.0 is being now with respect to is being measured. You have facility for this facilities in IIT
for
PM 1.0?
Well, I mean, PM1 is just a cut size. We can do that. We can change the flow rate and we can make it PM1. It's just that see, like these 2.51 are not, it's like simply that we are looking for smaller or fine size particles. Europe actually came up with PM1, while US came with PM2.5. We followed US.
But it's thought in the global literature that PM1 is more lethal or most lethal, and heavy metals among them are the root cause of all the causative agents for NCDs in nucleus.
So my kind of take on this is not from the epidemiological observational point of view. When you are saying lethal from toxicological point of view, all those studies are mass basis. So as soon as you divide the concentration by PM mass, PM1 is always more particles are needed to get that mass. Automatically it goes higher. So I would not necessarily say at this point whether PM1, PM2, but we should focus on the small one. Thank you.
Unfortunately, we are short on time, so we cannot